Breadth-first search is a common algorithm used to traverse data structures such as trees or graphs. For a tree, we start at the root node and then continue by exploring each of its children. Then for each of those child nodes, we explore each of their child nodes, and so on. This continues until we visit every node of the tree. Let's go through an example. Start at the root node at a depth of 0, represented in this tree as A. We see that A has 3 children, so we need to visit them next. In order to do that, we first need to think about how we're going to visit each of the nodes at the level below after we've descended to it. A queue data structure is perfect for this. Before descending, we store each of the child nodes in the queue in the following order: B, C, and finally D. This way, once we move to B, we still have a reference to the other children C and D since they're still in the queue. Great! We've got all the root node's children in the queue, so we can descend to the next level by removing the first node B from the queue and visiting that node. Now, just like with a root node, we need to add all of B's children to the end of the queue so we know to visit them after visiting each of the nodes at depth 1. Again, in order we add E and F to the queue. Then we repeat. Remove C from the queue and mark it as visited. Add its children G and H to the queue. Remove D from the queue and mark it as visited. Add its children I and J. Excellent, we're at the last level now at a depth of 2. Just like before, we remove the first node E from the queue, but in this case we see that we've reached a leaf node, meaning that it has no child nodes. So we don't need to add anything to the queue, we can just mark it as visited and continue. Remove the next node F from the queue. No children again, so just mark it as visited and continue. Remove G, then H, I, and finally J. Now the queue is empty and we've finished our traversal.